Hello there, Algebras. Welcome to your Chapter 14, Lesson 3, Day 1 notes on linear regressions. Finding a line of best fit. Actually calculating what would be a good fit for the particular data set that we have. So if we are looking at two variables of data and we graph them in a scatter plot, and we find that it looks like there's some sort of like linear relationship between the two, we can use our graphing calculator to actually find numeric values for a slope and a y-intercept that would describe what we call a line of best fit or a linear regression. So today, a lot of what we are going to do is rehash graphing a scatter plot using this particular data set that we have down here, fast food in grams versus total calories. And we are going to practice graphing this scatter plot of data. We are going to practice running a linear regression on this data set. And we are going to kind of start talking about what that linear regression can tell us about data we might not actually know yet. So let's start with, we have our graphing calculator in our hand. We have our RAM cleared. Let's start with entering the data into the graphing calculator. And we'll put the graphing calculator aside and do the scatter plot. And we'll come back to the graphing calculator. Okay. So let's grab the graphing calculator. And let's say that total fat grams are going to be our X, which is going to be our L1, and that calories are going to be our Y, which is going to be our L2. So we press Stat and Enter to get into L1, and let's start entering our data for total grams of fat in L1. Okay, and as we're going, the graphing calculator is telling us how many data values we have, and we'll just verify. So it looks like we have 11 data values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data values. Awesome. It's asking us for our 12th data value, which is how I know that. And it did turn out that that was the case. Now, when we arrow right to L2 to enter our total calories in this list, we want to make sure as we go that whatever the fat grams and calories that are supposed to match up as a coordinate are doing so. Because keep in mind, this is the coordinate 9, 260. Okay, that is the coordinate point on the scatter plot. So let's keep going with that. All right, so 260 starts us off, and we keep going. And again, as I'm doing this, I'm checking between the X value and matching Y value to make sure that they are continuing to be accurate. Okay, so that these points are together this way. And that also means that as you're doing this, you do need to have the same number of values in L1 as L2. So there can't be any stray values. That's a big indicator that maybe you entered something incorrectly. Okay, so again, as I went through, I checked what I was doing there. And now what I'm going to do, so as I was entering the data, I was also thinking about, oh, what's my largest data value? What's my smallest data value in each of those sets? And so what was I looking at being between? And so we know by putting our total fat grams in L1, that we will be plotting those as the x-axis. So total fat grams is going to be down here. We also know this is the same graph that we have previously used. So the kind of bolder points on here are 5s. We know that we have to get all the way up to 34, and we have a lowest value of 5. So if we're starting with 0, we couldn't go by 1s because there's only 20 places and we've got to get up to 34. So my guess is that we'll be going by 2s. to fit all those. So let's just double check. We have 34 divided by 20 slots. Yeah, we'll have to go by twos. Okay, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. And this is fat grams. Okay. Now, we also know over on the Y side, that's going to be our calories. And boy, our calories are going all the way up to 590. Okay, so being our max. Okay, so we got to start at 0. Let's take 590 and divide it by the 30 slots that we have here and see what we come up with. So we know this is the graph we've used previously. Well, this is indicating going by 20s, huh? So 20, 40, 60, 80, 100, 20, 40, 60, 80, 200, 20, 40, 60, 80, 300, 20, 40, 60, 80, 400, 20, 40, 60, 80, 500, 20, 40, 60, 80, 600. So when we're looking at this, we are trying to graph each of these coordinates. So 9 to 60. Okay. So here's 10, here's 8. Halfway between is 9. And we need to get all the way up to 260. So here we're at 9, 220, 240, 260. Right on there. Okay. Graphed. Now we're at 13, 320. So 13 is going to be halfway between 12 and 14. And we're going to head all the way up to 320. So there's 3, there's 320. 21, 240. So halfway between 20 and 22, 21. Sorry, did I say 240 and 420? 21. 420 is right here. Oh, we're looking linear so far. 30. 530. Holy smokes. It's up there. 31. 31, halfway between 30 and 32. And all the way up to 560. 31, 550. So that's just going to be right down here between 560 and 540. And also the 31 right below it. So same X value. 34 grams of fat. 34. And 590. Whew, almost to that 600. We are still looking very linear here with our points. 25, so that would be halfway between 24 and 26. And all the way up to 500. So let me stay halfway between. And 500. Oh, looking very linear. Probably a good linear regression that describes this. 28, 560. So here's 28, heading up to 560. 500, 20, 40, 60 right here. A little off kilter, but still within reason. 2440, 420, 40. Okay, still looking all right. And 5, 300, so 5. 2, 4, halfway between 4 and 6 right here is 5, up to 300. So that one's a little off. The rest of them, very, very nice linear look to this scatter plot of data. Okay, so this scatter plot of data is really telling me, yeah, this looks pretty linear. And again, this is our fat grams versus calories. And I didn't label the calorie side yet, so let me just do that. Calories. Calories are their own unit of measure. Okay. What is the data trending? It is trending linear. Okay, it is trending linear. And what I mean by that is as grams of fat increase, so do calories. So as the grams of fat are increasing, so do the calories in each of these sandwiches. So that's kind of telling me as X increases, so does Y. That would be a positive sloped trend. Now, what we're going to do next is prove that that is the case. So we're going to use our graphing calculator to run what we call a linear regression on this data. Okay, now these instructions on this page are going to tell me exactly what to do. So if you would like to be following along using this, you're more than welcome to. I am going to freeze my screen on my actual graph itself, as I am going to be saying what steps to take as we are taking those steps to get from our regular data in our list 1 and list 2 into a scatter plot and running a linear regression. So there are a few things that we're going to do right now that are really cool. And it's so great that our graphing calculator is going to help us with this. So grab that graphing calculator again. The first thing I want you to do, and this is going to be a real weird ask, but the first thing I want you to do is press mode. And I want you to arrow all the way down past the full and graph table. So all the way down past fraction type, auto answers, to stat diagnostics. And right now your stat diagnostics defaults to off. I want you to arrow right so that on is highlighted and press enter so that now stat diagnostics are on. So we want to turn our stat diagnostics on. Okay. Now I want you to press stat, arrow right to calc, and number 4 is the linear regression we like to use because ax plus b, y equals mx plus b. Ax plus b is the form we like to see of our linear regressions. There is another one, I don't use it. Okay, so number 4 is what we are going to use. So on this page, either arrow down to your linear regression and press enter, or press 4, and this is the next screen that we see. Notice it defaults to having our x's, what we want to be our x's, in L1, just like we did. And it defaults to having our y's, what we want to be our y's, in L2, just like we did. But there's a next piece I want you to enter that is pretty challenging, so I want you to listen up. We are going to arrow down to store reg eq. It stands for store regression equation. So arrow down so that your highlight is in store reg eq. And now press VARS, V-A-R-S. It stands for variables. It's right underneath your arrows. So my cursor is currently on it, and now I've pressed it. And this is the screen you should see. My red button is the last button that I pressed. On this page, I want you to arrow right to YVARS. It stands for Y variables. Okay? And you'll notice that there's a whole bunch of words on this page, and really the only one we know is a function. So please press Enter or 1 to get to this next page. And notice all this is a list of what's available to me when I press Y equals. And so what I'm going to do is I'm going to press 1 or enter on my Y1 so that I'm going to store my regression equation in Y1. Do you know what this means? This means that your graphing calculator is going to put your regression equation in your Y1 for you. You are not going to have to go back and do it yourself. Okay, so this is pretty cool. Are we ready? Let's calculate. So arrow down to calculate or press enter until you get to calculate. and you get a whole bunch of stuff that comes up. Now, the next page of these notes has spots for some of these things, but just seeing as I want to be on the data, I want to look at this, okay? So let's say our linreg, as it says at the top, is listing off an A value, a B value, an R squared, and an R. What's lucky about us is we don't care about the R squared. Not in this course. In this course, we care about the A, which I'm going to write out wholly. 11.73128088. We care about the B, which I'm going to write out wholly. I may not fit. 193.8521421475. Oh, just barely. And my R. So skip that R squared and go down to the R value, which is 0.974606741.8. Now, I know I was squeezing that into a very small space, but what I'm going to do right now is I'm going to write this as my y equals ax plus b equation, where I am going to round to the nearest, and again, your graphing calculator screen is asking you to write it right here. And I am going to round to the nearest tenth in what I write down right now. So y equals 11.7x. My a value rounded to the nearest tenth. So this was my a value. Plus my b value, 193.9. So my b value rounded to the nearest tenth. Okay? Next, we're going to look at this on our graphing calculator on a scatter plot, and then I'm going to talk about all of the implications of this. So please press second and y equals on your graphing calculator. We learned yesterday how to graph our scatter plots on our graphing calculator. So in order to get into a stat plot, we press enter, enter, and turn it on. So plot 1 is now on. Notice plot 1 defaults to a scatter plot with an x list of L1 and a y list of L2. Just like running the linear regression defaulted to an x list of L1 and a y list of L2, and I tend to default to an x list of L1, a y list of L2. Well, that's on purpose because I'm using this graphing calculator to help me. So now, if you press zoom 9, your graphing calculator will graph that scatter plot for you. And because you had told the graphing calculator to store your linear regression in Y1, you can see what that linear regression looks like on your scatter plot. So you are getting the idea of, well, wait a minute, approximately this many points are above it, approximately this many points are below it. You're getting the idea of where that looks like and where that goes to. Now you'll notice that a weird thing about this is our y-intercept is not 0, 0. Wouldn't you think if you had 0 total fat that you'd have 0 calories? That wasn't thought about here, was it? Our y-intercept, our b value here is 193.9. So approximately here is my y-intercept, approximately right there. So it's saying if I have 0 fat, I could still have 200 calories almost. Interesting. Our slope, our m, is about 11.7. That is telling me that for approximately each calorie, about 11 calories, I am going to get 1 more gram of fat. Because remember, slope is y, the change in y, that's my calories, divided by the change in x, that's my total fat. So my slope is describing how I'm moving up the graph as I'm looking at an approximation of a line of best fit, a line that will fit these points the best. Now, these points are not perfectly linear, are they? That's described using the R value. which I am going to talk in depth about tomorrow. Okay, so you'll notice that on the back of this, where I have the graphing calculator screen to do the fill-in, there is no R value here like I had you do today. That's because tomorrow I'm going to talk more in depth about this R value in class. However, when we turn our stat diagnostics on, which is what we're going to want to do every time, we are actually getting a value that rounded to the nearest hundredth. So I'll round that to the nearest hundredth, is giving me approximately how well correlated or related this data is to each other. So as your total calories increase, as your fat increases, so do your total calories at approximately a 97% accuracy. Okay, this line of best fit is approximately that accurate to this particular graph. Okay, so if I kind of think about, well, each of these lines is 2 and each of these lines is 100, I could turn that into a slope, right? Or I can just kind of guesstimate, and I'm just going to kind of guesstimate a few points above, a few points below, so we can have an idea of what a line of best fit looks like on our graph. Okay, it is certainly a positive slope, right? The slope was positive. So as my total grams of fat were increasing, so were my calories. And so that's the direction that the slope of this line of best fit is going. Okay, it's giving me that type of situation. But what this is doing is helping me to then predict if one of my sandwiches had, let's say, 14 grams of fat, approximately how many calories would that sandwich be? So this is helping me do a prediction. If you press second and graph and look at approximately 14 grams of fat, so your X value of 14, what is your matching Y value? Oh, it's about 360. What was our matching Y value? About 360. So this is helping us to make predictions based on what we do know with the data we have collected. Now, will this be perfectly accurate? No, because every new data value helps us to tweak and refine this better. Will this be perfectly accurate? No, because look how far apart some of these points, some of our coordinate points of our data gathered are away from this line of best fit. It isn't perfect because our data was not perfectly linear. However, it gives us a really good idea when we're thinking about things like this. And so we can use this to help us make these predictions. Now, I do want to show you one more thing before I'm done, which is if you press Y equals and arrow down to Y2, we're going to type in our decimal rounded linear regression that we wrote right here. Okay, so the rounded linear regression that we decided to write out here, rounding to nearest tenth, I'd like to put that in my Y2. So we're going to type in 11.7x plus 193.9. And just press graph one more time. And you can see that even with that rounding to the nearest tenth, this linear regression is about the same as the other linear regression that did not round. It went way out in its values, its decimal values. But what I do want to show you is second and graph are the table of points. And just a quick look at the difference between 14 when we're not rounding and 14 when we are rounding. It was a little bit less, wasn't it? So be careful as to how you're asked to make your predictions. If you're asked to make any predictions with a rounded version of your linear regression or an unrounded version of your linear regression. Okay, so I just want you to kind of consider that and be careful there. I did on this particular screen, so I wrote this where we can plug in the stuff from our graphing calculator, so I'm just going to do this. and just run the regression one more time to show you that I did get an A value of 11.73128088 and a B value of 193.852147.5. And again, just so that just for the sake of filling in our notes. And then down here on D, round to the nearest tenth. Oops, nearest tenth. So this would be our y equals 11.7x plus 193.9. Now, all of your graphing calculator pieces are typed out for you to practice on your own when you are working on your homework. So on your 14-3 homework number 1, we are going to actually be running linear regressions, and you will actually need your graphing calculator in order to do so. So if you don't have a physical graphing calculator, you can use Calculate 84. That is an option if you have that on your phone, okay? One other thing that I would like to just do real quick is just show you screen-wise. If I were predicting 22 grams, that's an X value of 22. And I can use my graphing calculator table to do that, both in the rounded version and the unrounded version. Okay, you'll notice on my screen I didn't have a rounded version of that. But if I want to look at an X value of 22, and I want to look at the unrounded version versus the rounded version, they are really close, aren't they? So unrounded, so as is, it is 451.9, let's say. And rounded to the nearest tenth, we have 451.3. Look how close that is. If we were rounding to the nearest whole calorie, we would round this up to 452. However, this one would stay at 451, but that is pretty darn close, even with that rounding. So we just want to be careful about if we're rounding our regression equation or not. So just be careful about that when you're looking at this. This is something that our graphing calculator does for us and something that the Regents asks us pretty much every year. Now, I will talk tomorrow more about that R value, that correlation coefficient, that kind of helps us determine how well related are these two data values. And is this a good predictor? A 0.97, just a spoiler alert, is a great predictor. An R value of 0.97 is a great predictor of what other calorie counts would be based on our fat grams that we're given. Okay? All right, my fine friends. Good luck on 14-3 homework number 1. Let me know if you need any help. Use the graphing calculator. Use these instructions of how to use the graphing calculator. Do not sleep on this. It will be a 4-point question on your Regents. I will see you tomorrow for correlation coefficient. Thank you so much. Bye, Algebra Crew.